Hello and good day everyone. My name is Koo Keung Eng and today I'll share with you a collaborative project that me and my colleagues had worked on that is on school level standardized assessment. So this work will not have been possible without their full support and my fellow chemistry teachers obviously, so they are listed here. I would also like to acknowledge the PT Tutong School Administration for their continuous support throughout the duration of the project. Now we all know that examinations and their subsequent examination results, they have high emotional prices to pay, whether it's happiness or the feeling of satisfaction, regrets or despair. And that's not just on the student perspective, there's also from the teacher's perspective as well. So to overcome that, how can we be more realistic in reporting school grades so that they actually reflect the attainment in the actual public examination result? This has become particularly relevant this year, especially since Cambridge International Examination Body that had just cancelled the June 2020 examination series. That's as a result of COVID. So, but Cambridge still decide to publish and award grades to students who have registered for the exam. This will depend mainly on the mock or qualifying examination results that happen in school, in addition to other supporting evidence. Before I delve into the results of our study, I'd just like to clarify on a couple of terminologies. So the standardized assessment here refer to the school level, qualifying or mock examination. We normalize the marks, basically I'll talk more later, but we basically normalize the marks and we translated these to grades, which we provided to Cambridge eventually. So there's the forecasted grade. In the study that I'm going to go through today, we have compared that forecasted grade to their actual examination result, which is from the A-level examination, and this data were compared for 3 consecutive years from 2015 to 2018 cohort of students. I'm now going to go through very quickly the 5 stages of our in-house standardized assessment procedure. The first 2 stages took place before students sat for their mock exams, and the latter 3 stages took place after they have sat for their mock exam. In stage 1, we basically met up a couple of weeks before the mock exam were due. We finalized learning objective to be assessed, and we delegated the task among ourselves. We reviewed this further in stage 2, which took place usually a week after stage 1. By this stage 2, we would have gotten our draft copy, which we would revise. We would scrutinize each other draft copies to ensure that the same learning objective have not been repeatedly tested across the different components, because we want to stretch the candidates across as many learning objectives as possible. Stage 3, as mentioned, took place after students have sat for the mock exam. Here we will randomly split up the script so that we are not marking just our own set of students, but also from other teachers or other tutors as well. We would then set out in this stage to mark about 20% of the script assigned to us, and this is simply to take note of any ambiguities or irregularities so that we can make noteworthy amendments on the marking schemes as provided by the setter. And this brings us to stage 4, where we will discuss these ambiguities. We will discuss how lenient or how harsh do we have to be, and that is to be agreed uniformly by all the markers. So we will then set to revise the marking scheme, and together with that revised marking scheme, we would set out to mark copies of the same script with the objective of reaching consensus on the final score. Because if we are all marking to the same standard, if we are marking the exact same script, all of us should come to the same final score. So this standardization continued with a few other script copies so that we can reach that consensus on the final score consistently. And then we went away and completed the rest of the marking in our own time. The final stage of our procedure, stage 5, is where we group together the common weaknesses, the common mistakes, the misconceptions that we had encountered from the students during our marking procedure. So we put this into a document, and then we cascaded this document with our students in our own correction classes. But the most important moderation we did at this stage really was the normalization of the marks. That is to do a bit of curving in order to achieve a normal distribution that looks more like a bell curve. So this is the statistical formula that we use from the Excel file. You can email me if you wish to have a copy of the file, and I'll be happy to elaborate on the procedures further. Cambridge publishes this thing called grade threshold. So grade threshold looks something like this. Oops, I beg your pardon. Grade threshold looks something like this. So it specifies the minimum marks required out of the total raw mark in order to achieve that particular grade there. So for example, C there. So if you achieve 129 to 151 out of 260, you are going to be awarded a C. Alright, so if you translate those into percentage out of 260, A star all the way to E is going to give you these particular percentages. I've circled here in blue color here. This is the percentage that you get from the grade C by dividing 129 out of 260. That's around 50%. In our normal distribution, so in our Excel file when we do the curving, we aspire to get an ideal average of around 60%. So that's just quite conservative compared to the actual grade C that is being set by Cambridge in this grade threshold. So how much, the extent to which we actually curve or normalize, it depends on a multitude of factors, one of which was difficulty of exam, the quality of the cohort, how reliable our examinations were, more importantly, the judgment call from the more experienced teachers, because they have seen it, they've seen how the student quality vary year after year. And lastly, more data, because statistical analysis depend and they fit on bigger data pool. So here in this example, you can see that this bar chart in orange, they are labeled as transform grade. So they represent the distribution of the grades that have been transformed, whereas the bar chart in blue at the back there, it represents the distribution of the original grades before you do any transformation. So by changing this value of P, that ranges from 0 to 1, if we don't change anything to the value of P, we just keep it as 1, then we are not doing curving. If we do curving by lowering the value of P, then it's going to increase the average. So the curve average is higher than the raw average. So different years, the quality of the students are not consistently the same. So some years perform better than others. So you can see that when you start to curve, the orange curve starts to look more like a bell curve now, a bell curve that centers in the middle. This is a particularly strong year group, so instead of a bell curve, your bell curve is skewed to the right hand side, which is the stronger grade. In our quantitative study, we use this software called SPSS. We are a mixed gender school, so we are a co-ed school, but we did not investigate gender difference in our study here. Instead, we converted the grades into numbers that we then key into SPSS, and we did this for the actual grade that they got in their A-level exam. We compared it with the forecasted grade based on the school level standardized exam. We came up with this null hypothesis that we postulated there is no significant difference between the two grades as I mentioned previously. I'm not going to go through all the statistics in detail, but basically these statistics, you can believe me because I did this on SPSS, they reveal a very strongly and positively correlated relationship between the two grades. That is good. So the maximum value of R here should be 1. So when it's 1, it means 100% correlation. So we are very close to 1. 0.846 is very close to 1. That is a very strong and positive correlation. And it's significant because this value is lesser than 0.05. So in the paired sample t-test, we can establish that there is no statistically significant difference between the two grades because this significance is greater than 0.05, so there is no significant difference there. One grade difference is 1 point, and you could see that the mean difference is lesser, so much lesser than 1, and very close to 0. So in conclusion, the statistic I showed earlier means that we do accept our null hypothesis, which is that first conclusion there. I also wish to reiterate that our reliable in-house standardized assessment approach was a collaborative effort. It would have been impossible with just a single person input. The same approach can also work with other subjects in any other school level, whether you are primary or secondary level, and in fact they will benefit from a greater pool of students, which make big data analytics more reliable. I've come to the end of my talk. Thank you everyone for listening.